Good day, everyone. In this video, we have to study and sketch the graph of the absolute value of y minus x plus the absolute value of y, which is equal to 2. And we are going to start by defining the absolute value of y minus x, which is equal to y minus x if y is greater than or equal to x, or x minus y if y is less than x. We are also going to define the absolute value of y, which is equal to y for y greater than or equal to 0, or negative y if y is strictly less than 0. And this leads to 4 different cases. And we are going to analyze this equation for all these cases. Now let's start with case 1. That is y greater than or equal to x and y greater than or equal to 0. For this particular case, the absolute value of y minus x is equal to y minus x, and the absolute value of y is just equal to y. And therefore, from the given equation, we're going to have y minus x plus y, which is equal to 2. And so this implies that 2y minus x is equal to 2, which implies that 2y is equal to x plus 2, and that y is equal to half into x plus 2. But we know that y is greater than or equal to x. And so this implies that half into x plus 2 is greater than or equal to x, which implies that x plus 2 is greater than or equal to 2x, and that x is less than or equal to 2. We also know that y is greater than or equal to 0. And so this implies that half into x plus 2 is greater than or equal to 0, and that x is greater than or equal to negative 2. And therefore, from case 1, we can see that y is equal to half into x plus 2. And this holds for negative 2 less than or equal to x, which is less than or equal to 2. Now let's take case 2. That is y greater than or equal to x and y less than 0. In this case, the absolute value of y minus x is equal to y minus x, and the absolute value of y is equal to negative y. And therefore, from the given equation, we're going to have y minus x plus negative y, which is equal to 2. And this implies that negative x is equal to 2, and that x is equal to negative 2. Now recall that y is greater than or equal to x, that is, y is greater than or equal to negative 2, and that y is less than 0. And so from case 2, we can see that x is equal to negative 2, and this holds for negative 2, which is less than or equal to y, and this is strictly less than 0. Now let's take case 3. That is, y is less than x, and y is greater than or equal to 0. In this case, the absolute value of y minus x is equal to x minus y, and the absolute value of y is equal to y. And therefore, from the given equation, we're going to have x minus y plus y, which is equal to 2. And this implies that x is equal to 2. But we know that y is less than x. That is, y is less than 2, and that y is greater than or equal to 0. And therefore, case 3 leads to the line x equal to 2, and this holds for 0 less than or equal to y, which is strictly less than 2. Now we take the last case, which is case 4. That is y less than x and y less than 0. In this case, we know that the absolute value of y minus x is equal to x minus y, and the absolute value of y is equal to negative y. And therefore, from the given equation, we're going to have x minus y plus negative y, which is equal to 2. And this implies that x minus 2y is equal to 2. That is, 2y is equal to x minus 2, meaning y is equal to a half into x minus 2. But we know that y is less than x. And so this implies that half of x minus 2 is less than x, implying that x minus 2 is less than 2x, which implies that x is greater than negative 2. We also know that y is less than 0, and this implies that half of x minus 2 is less than 0, implying that x is less than 2. Case 4 is such that y is equal to half into x minus 2 for negative 2 less than x, which is less than 2. So here is the summary of the 4 cases. We have case 1, case 2, case 3, and case 4. Now we can present this information on a graph. In case 1, we have this line which can be drawn for values of x between negative 2 and 2. So when x is negative 2, we have y to be 0, which is this point. When x is 0, we have y to be 1, which is this point. And when x is 2, y is also 2, which is this point. So this gives us the line segment, this. Next, we get to case 2, where we have the line x equal to negative 2, drawn for values of y between negative 2 and 0. Now, when y is negative 2, x remains negative 2, which is this point. And when y is 0, x remains negative 2. So this gives us the line segment, this. In case 3, we have the line x equal to 2, and this is drawn for values of y between 0 and 2. So when y is 0, we have x to be 2, and when y is 2, x remains 2. So this gives us this line segment. Lastly, we take case 4, which is the straight line y equal to half into x minus 2, and this is drawn for values of x between negative 2 and 2. So when x is negative 2, y remains negative 2, which is this point. And when x is 0, y is negative 1. So this gives us this last line segment. Therefore, the absolute value of y minus x plus the absolute value of y equal to 2 is the equation of a parallelogram as shown above. Thanks for watching. Please do remember to subscribe to this channel for more exciting videos.